Okay, so before I get into the main topic, I'm not going to teach about drawing because I asked the teacher, do we need to use protector? And he said no. That means there's no drawing involved. It's all going to be calculation based. So the textbook for some reason does not actually teach calculation that much. So I am going to try and explain this myself to you guys. So it's you guys and girls and everyone else in between. Uh so let's get into it. Resultant force. This is going to be the most annoying part that I'm going to teach. Other than Archimedes. So resultant force is if you have multiple forces applied together. Like for example, let's say for example this guy pulling. You're doing the pull thing. So you are pulling from two sides. So you have a force pulling from the right and also pulling from the left. The resultant force is the total force over here. Now remember that force is a vector quantity. So you have to take into consideration the direction of the force. For example, if I were to add two forces here together, and if I have two forces coming together at the same direction, the resultant force is adding them together. But if I have a force going like this and a force going the other way, then I have to minus. So yeah. This one is pretty easy to understand. If one is heavy, if they are both equal forces, then the resultant force is zero. So we call that equilibrium. Forces in equilibrium. And that is going to be the main part they'll teach later. But if you have a force that is greater than the other, then you say that the force extends by that the force is greater. Yeah, if you have a force that is greater than the other, for example, let's say the guy on the right is stronger than the guy on the left. So if the guy on the right is stronger than the guy on the left, then obviously when you pull, when the guy on the right pulls, then the guy on the right would pull the guy on the left, right. That means that the force is going this way. So again, if let's say the guy on the right is stronger than the guy on the left. So if the guy on the right pulls, the force is stronger here. So it will cause the guy on the left to move with him. Why? Because the resultant force is towards the right. And that's because he has a greater force. So yeah, if one force is greater than the other and they go opposite directions, the resultant force would be the greater force minus the smaller force in that direction. For example, if here is 5 Newton and here is 2 Newton, then the overall force will be 3 Newton to the right. Because 5 minus 2 is 3, and the stronger one is on the right. Okay, so that's for the simple forces. Again, at least I don't have to teach this part. I hope doesn't come on an exam at least. But teacher mentioned that there is no protector coming out, and no protector needed. I hope it's not actually playing around with me. But he said that he also mentioned that we don't want to do that because the numbers are too inaccurate. So thank God, I don't like using protectors at all. I don't like using the compass or whatever it is. I don't like using the ruler and so on. I prefer pure calculation. And I know most people don't want that, but it is what it is. So one thing, if before you know how to calculate the resultant force, you need to find out what are the forces. So a basic one would be they're all under the same plane. For example, the book. You see that the book is attracted by gravity. So there's a weight of it going downwards because it's the weight is pulled down by gravity. I mean the weight is the gravity pulling down the book. And then the normal reaction from the table here is when the book gets pulled by gravity, the table has to respond, right? So the table responds by trying to push it back up. If the table can respond enough, then the book will stay on the table. But if the book is too heavy, the table will break because the normal reaction is not enough. That means R is greater than that means the weight is greater than the normal reaction. So if the weight is greater than the normal reaction, the book will fall down. If the weight is less than the normal reaction, which doesn't happen, then the book will float up. But if the weight is equal to the normal reaction, which it almost always is, I mean in calculations we always assume that it is, then it will stay in equilibrium. It will stay on the table. And then for the back, again, we have the weight pulling it down. And then another thing is you have to consider that the bag is leaning against the triangle thing, the wedge. So when it goes against the wedge, of course the wedge has to respond, right? So it reacts with a normal reaction. And then since the bag is on a plane, so the bag is exerting pressure towards the plane, not pressure, force towards the plane. So of course the plane has to respond with its own reaction. Okay, I hope you get it. And then sometimes it will get even more complicated. For example, a lorry. The lorry is moving to the right. Right. So when the lorry is moving to the right, or moving in one direction, it will the engine force will force itself. The engine will have the force to move it in one direction. But then since it's on the ground, there will be frictional force going the other direction. And then since it's also on the ground and there's gravity pulling it, then there'll be weight of trailer. And then you have to consider the weight. And then since every action there is a reaction, you have to you have to consider the normal reaction as well. So yeah, you have to understand where the forces are and how to apply them. Okay, so again, you also assume here W equals to R, W equals to R, W equals to R. The weight is equal to the normal reaction, because if it's not, the thing will either float or crash on the ground, and you do not want either of them to happen. Okay, so if the object is in a stationary state or in uniform velocity, or in other words, simply in inertia, then the resultant force would be 0. Why? Because you have an equal force. You have an equal force going this way and an equal force going the other way. So if you have an equal force going one way and an equal force going the other way, your resultant force is 0. But you might be wondering, what? My car is moving, so wouldn't that mean that there is some force? Yes, there is force, but I'm talking about the resultant force. So remember, force is equal to ma, mass times acceleration. When your object is moving at a constant velocity, there is no acceleration. So that means a is equal to 0. So F is equal to m times 0. So F equals to 0, right? So yeah. Even if the object is moving, if it's moving at a constant velocity, we say that the resultant force is equal to 0. Okay, what if the object is moving with acceleration? Then that means the resultant force is your force, the engine thrust, or the force moving forward, the pulling force, minus the frictional force. But it's not always going to come out like that. Okay, I answered this question with my friend. So sketch the free body diagram of the coconut. So when the coconut is falling from above, it will get pulled down by gravity. So there's weight. But then remember that the air has friction. So the air, so even though it's not much, it's still going to cause a resistance on the coconut. So you have to consider the air resistance as well. And then calculate the resultant force acting on the coconut. So that one's easy. F equals to ma. So F equals to ma, because this thing must 2 kg acceleration of 9 ms per second. It already considers the both forces. So you can write it immediately. So F equals to ma. And then state the direction of the resultant force. So since it's getting pulled downwards, so you will say it's downwards. And then what is the magnitude of the air resistance acting on the coconut? Now this is the interesting part. So you know that the overall force, the resultant force, this is the resultant force, resultant, is equal to 9 times 2, right? I'm going to go to the next page because it's over there. So 9 times 2. And then the resultant force is the weight minus the friction. So the weight minus the friction, the weight is equal to 9.81, because that's the gravity punya. Because remember, it's getting pulled by gravity, times the weight, so it's 2. So 9.81 times 2 is 19.62. then you want to find the reaction force. So 18 is equal to 19.62 minus R. You do some very easy maths and you will get R equals to 1.62 N. So the friction coming from the air is 1.62 N. Okay, let me see. Teacher mentioned that this isn't coming out either, so I'm not going to mention this as well. Even though I did try to study this part last time, but apparently it's not coming out. But for the lift, this is another easy one. So remember, you have weight going downwards, but the lift gives a normal reaction and it's equal to the weight, because if it's not equal, you'll be falling off or you'll be floating in the air. So again, F equals to 0. So again, since it's equal, F equals to 0, and you know that there is the normal reaction, right? You want to find the normal reaction, ma. Yeah, you want to find the normal reaction when it is stationary. When it is stationary, when it's stationary, that means the resultant force is 0. So when the resultant force is 0, that means the weight is equal to the normal reaction. So it means 60 times 9.81, because 60 is the mass and 9.81 is the gravitational acceleration. So your resultant force is 588.6. How about this one? Moving upwards with an acceleration of 1.2 ms minus 2. And 3 is moving with a uniform velocity. Okay, I'll explain this one. Uniform velocity. Since it's moving with a uniform velocity, remember that I mentioned the resultant force is 0. So R is also 588.6 N Newton. But how about when it moves upwards? So let's say we first of all, we know that it moves upwards. So when you're talking about upwards, we want to make everything go upwards as well, if you get what I mean. You see that normally you will write W minus R, but in this case it's R minus W, and that is because this thing here moving upwards shows that R is greater than W. When R is moving upwards, R is your normal reaction. So if your R is greater than W, then wait. Okay, when your R is greater than W, it means that your resultant force is also going upwards, because the resultant force decides the resultant force is the sum of two forces. If your R is greater than W, then your force will act towards R. So you might be wondering, why don't I float in the air then? That is why don't I get squished then? Remember, the resultant force is upwards. So when you go up the lift, right, you know how your legs, they don't really feel on the ground. You feel like you're floating a bit. That is because your R is greater than W. And then if you go down the lift, you'll feel like you're falling downwards. So that's because the weight is greater than the normal reaction. So so remember, as I said, normally we consider that W equals to R, but in like those lift situations, if the lift is moving upwards, then the normal reaction is bigger. If the lift is moving downwards, then the weight is bigger. So we put the big one first. So R minus W equals to MA, and then you do the calculation. R is equal to 660.6 N. So remember that when you want to answer the force, normally you want to try and answer it with the direction. So for example, 660.6 Newton upwards. Okay, I don't want to teach this part, because teacher said it's not mentioned, it's not coming out. So I don't think people want to listen to this part. So yeah, I'm just gonna skip this one. Okay, this is where we get into the part where everyone starts to not understand anymore. Okay, Resolution of forces is resolving a force into two components. So you want to try and separate a force into two. Because normally when you want to do calculations, you want to do it in a straight line, right? Straight line, straight line. But what if you have a force that goes like this? For example here, I am the boy is getting pulled this way. But then you want to find you want to find the what yeah, you see that the thing is getting pulled in one direction, but you want to try and make it so they are more in line with the whole thing, because this thing is going horizontally, this is going vertically, this is going vertically. So you want to separate this force into horizontal force and also vertical force. Oh, it's balik. Vertical and horizontal. So yeah, resolution of forces is trying to turn this into these two forces. So how do you find that? First of all, they will give you the angle in which the force is acting at. For example, the force is acting at an angle of theta to the horizontal. So it's at this direction. Theta to horizontal means the gap between force and theta is force and the straight line here is theta. And then you want to use calculation. Force acts similarly to length. So you can make a right angle triangle out of this. Right angle triangle, right angle triangle. So theta. So sine theta is equal to the opposite, right? Opposite over hypotenuse. So this Fy is equal to here, also Fy. So opposite equals to Fy over F. So Fy equals to F sine theta. And same thing for cos. I think I made a mistake by not talking more about the calculations. But that's because I'm going to go and talk about it now. Again, I'm not going to teach you how to draw, but I am going to teach you how to find the force in the middle. The easier one is when it's a right angle triangle, then you know what to do. You use Pythagoras law. Because the thing is, right, force acts similarly to length. So if here is 3 Newton and then here is 4 Newton, then here is 5 Newton. Here is 3, here is 4, here is 5. So if here is 3 cm, here is 4 cm, and here is 5 cm kan? Same with forces. If here is 3 Newton, here is 4 Newton, and here is 5 Newton. So you can use like some identities that you will normally use in triangles with length to use in forces. Like sine rule or Lami's principle, as well as cosine rule. So how will I use sine rule and cosine rule? Okay, let's say I'm going to make a random question. And I'll use this free space. Right. Let's say I have 6 Newton and 8 Newton acting at a direction of 30 degrees to the horizontal. So first of all, you want to identify where your triangle is. So the way you identify it is what again? You want to find the force in the middle, right? So I'm gonna draw it out first. The drawing is still important. It's just that you don't have to calculate using the drawing. You just have to use a rough sketch to know what you're doing. So let's say you have 6 and 8 at 30. So 6 Newton, 8 Newton at 30 degrees. First of all, you want to try and find your triangle. So the way you want to try and find your triangle is what again? Okay, first of all, what I normally do is I extend to the back. So I extend it to the back. Right? So I extend it to the back. And then after that, it's the same length, right? I connect these two together. So this is the final force. So if you don't get what I mean, remember that length acts similarly to force, or force acts similarly to length. So if here is 8 cm and 6 cm, then you will then they will have a specific area, a specific length in the very end, right? They will have a specific resultant, a result length. I mean like a specific gap. Like for example, if here is 3 and here is 4, then here is definitely going to be 5. It cannot be like 5.1, 5.3, 6.2. No, it will be 5 because that's how the length works. Same thing with force. That's how the force works. If you were to extend it here, the final force, and then you try and trace it behind, and you draw it again. Here's what I like to do. So let me just do it again. 6 Newton and 8 Newton, and then here is F. Remember, my thing is not drawing up to scale. The resultant force, right? You have twists to draw it. Let's say I draw it the other way. So I extend this one as well. I mean, I draw the same thing here. The length between the gap between the distance between here and here is your final force, your resultant force. Now, first of all, how do you find the resultant force? I said earlier that the theta here is 30 degrees, right? So you know that here is 6, you know that here is 8, and you know that here would be F. So you want to find F. So how do you find F? Wait, the first thing you have to do is, oh my bad, this whole thing is 30. Okay, this whole thing is 30. So if the whole thing is 30, then remember that these two are parallel to each other. So if here is 30, here is 180 minus 30. So it is 150. So so it's 180 minus 50. So here is 180 minus 30. So here is 150. So you remember cosine rule, right? Cosine rule is a square, c square equals to a square plus b square minus 2ab cos c. So this squared plus this squared minus 2 times this times the cos of the angle opposite it, the angle facing it. So here is 150. So you just sub it into your calculation, and then you'll get your final length. Now the thing that people always ask me is how do I sometimes teacher uses plus 2ab cos c. So so who's right? I am wrong. Why am I wrong? Okay, I'll give you 5 seconds to think about it. Why am I wrong? Okay, so get back to it. Why am I wrong? So you know how the triangle here is 150 kan? Okay, wait. I'm not exactly wrong, but most people will just use theta here, where theta is your angle of this thing. So you want to be careful if you're using this or this. So you have to be careful because cos theta is equal to negative cos 180 minus theta. So if I have cos 30, is equal to minus cos 150. So I put minus here. Because I already did the 180 minus 30 thing. But if you haven't done the minus, you have two choices on how to do it. Number one is you immediately put it as c square equals to a square plus b square minus 2ab cos 180 minus theta. So that's the first thing you can do. You can immediately just put it in like that, where theta, remember, theta is your angle here, not here. Theta is the angle between the two forces, not the angle in the triangle. So you want to do 180 minus theta because you want to find that angle in the triangle. But you can also use your big math brain and remember that cos 180 minus theta is equal to minus cos theta. So c square equals to a square plus b square minus 2ab minus cos theta. Then minus minus equals plus 4. So that's why people use, that's why teachers use plus. So if you don't get what I'm saying at all, just note, I'll just tell you one thing. If you want to use cosine rule with plus, use the angle that they give you. If you want to use cosine rule with minus, you do 180 minus the angle first. Okay, so that's to find the final force here. So so your c square here is f, your a square is f1, and your b square is f2. So f square is equal to f1 square plus f2 square plus 2f1 f2 cos theta. Okay, now how, so sometimes you will get the let's say after you get the value gun, let me do it myself first. So c square is equal to 36 times 64 plus 64, oh yeah, plus 64 plus 2 6 8 cos 30. So you add it together, 36 plus 64 is 100, I think, plus 12 plus 8 is 96. 96 square root 3 over 2. So yeah, if you have like weird angles, you can use calculator to find the answer. But yeah, you will, if you use calculator, you'll get the final answer. Remember the square root. Remember the square root. So so that is how you find this thing. But how do you find, they give you the angle, they give you the angle 30 degrees kan? How do you find the angle between here and here? Now you might be asking me, why do I have to find the angle between the new force and your horizontal plane? Because remember, you want to specify the direction of the force. So you cannot specify it goes right or left, because it's not going right or left. It's going right and up a bit. So you want to specify it in terms of degree. So you want to say how many degrees towards the horizontal plane. For example, x degree towards the 8 Newton plate, 8 Newton force. So how do you find it? Remember the triangle again. So here the triangle. This time you know what f is already, kan? And then you know that this is 150. And then you know that and you want to find this one. Right, you want to find this new angle. I'll call it alpha. Remember that this is f1 or y. Then you can put it here as well. So now you have another rule. Lami's theorem or sine rule. I forgot which one is Lami's theorem, which one is sine rule. But basically it's the same thing. f1 over sine alpha is equal to f over sine theta. So how do you know which one is the alpha you want to use, which one is the angle, and which one is the force you want to use? Again, look at the angle that is facing the force. So f1 over sine alpha equals to f over sine theta. But Anas, isn't theta 30? Why are you not using the 150? Again, remember sine 30 is equal to sine 180 minus 30 equal to sine 150 kan? So you see that this time it's positive for both, positive and positive. For cosine, if you want to convert to 180 minus theta, it will become negative. But for sine, it stays the same. So you don't have, so it doesn't matter. You can use 30 here as well. 30 or 50. Both are harmless. You can use both. So I hope that's understandable. So that's how you find the angle. Then after that you will get the magnitude of force is alpha Newton is F Newton. How many Newton towards at a direction of how many angle towards the force at the bottom. So let's say you have let's say your alpha is equal to 30. Oh no, 15. And then your F is equal to let's say your F is equal to 10. And then your F2, the F at the bottom here, F2, is equal to 5. So the way you want to write it is the resultant force is 10 Newton at a direction at a degree of 15 degrees to the 5 Newton force. That means the difference, the gap between the 10 Newton and the 5 Newton is 15 degrees. So yeah, this is when I'm talking about resultant force. This is still about resultant force. So remember, there are a few types. Number one is they are together at the same direction. Number two is they are at the opposite directions but at the same plane. Number three is they are at different planes, like they are at completely different directions. So if you have completely different directions and you have two forces, you solve it by using cosine rule, use cosine rule, and then use sine rule. So if you want to ignore all my teaching, just remember cosine rule is c squared equals to a squared plus b squared plus 2ab cos theta, and then f1 over sine alpha is equal to f over sine theta. So yeah, that is for two forces. How about okay. Yeah, let me just look at this first. Oh, I'm tired. How about multiple forces? I'm gonna come back to this later. How about multiple forces? So again, this only works if your forces are in equilibrium. If it's no, I mean for any more than two forces, this triangle thing only works if your thing is in equilibrium. But for now, we only learn about three forces. So 1, 2, and 3. So okay, let's say you have a force at 1, 2, and 3, and the resultant force F is equal to 0. Okay, so let's say the F is equal to 0. So you know the F is equal to 0. Then what you have to do is you have two ways of finding it. One is separating them into two planes, like so it's one going up and down, and then the other one is going left and right. And the way you do that is by what, as I said earlier, resolution of forces. You separate them into two planes. The other one is by immediately using sine rule, and that is because there is something called triangle of forces. So yeah, if the forces are not in equilibrium, you use this one. But if the forces are in equilibrium, you use triangle of forces. So what is triangle of forces? You arrange them into a certain pattern. So for example, this one is going downwards, the other one is going this way, and the other one is going that way. So if you were to put them, if you were to make it so it becomes a triangle, it will be a perfect triangle. It will be a perfect triangle. Like it won't be like this. Because remember, forces act similarly to length. So if your equilibrium is equal to 0, that means if your resultant force is equal to 0, you can do the triangle thing. But again, I don't like doing triangles. So I'm gonna go back to here. I'm gonna go back into here and immediately use sine rule. So how do I immediately use sine rule? So let's say you have an angle like this. Oh, it's too big. Angle like that, and then an angle like this, and an angle like this. So you have three, right? Three, 1, 2, 3. So if here is F1, F2, F3, and then this is I'll just call it A, B, and C. So again, using sine rule or Lami's theorem, F1 over A is equal to F1 over sine A is equal to F2 over sine B is equal to F3 over sine C. So yeah, if you don't even want to know the formula, just stay here, just stop here. But if you want to know why, let me explain to you why. So so remember at first, give me a bit. Okay. Wait, I'm going blur again. I remember teacher mentioning why, but yeah. Okay, first of all, you know the formula. remember, it is the angle facing the length. So f1 over a equals to sine a equals to f2 over sine b and f3 over sine c. So yeah, you have to know that. And then the reason why is because wait, if I don't remember what teacher mentioned, oh yeah, okay, I remember now. So it's also something to do with the triangle, because remember, we're talking about equilibrium here, so we can have a triangle of forces. So when you have a triangle of forces, it will perfectly align. So if I have this, right, I'm going to make it less hard to look, easier to look at, hopefully. So this is f2. So again, the way you want to draw a triangle is because you want to try and connect them like a reaction. So the arrow goes until here, and then after that the arrow continues down. But remember, it must be in the same direction as it was here. So I'm gonna use this one, go down, and then this one, go up. So you have so wait, I'm just, oh, that's so ugly. I wish I had a bigger paper. Okay, I'm gonna use the notes instead. Oop. So yes. Okay. So let's say you have forces in equilibrium going in certain directions. If it's perfect enough, you can make it so it will become a perfect triangle. Right, you can make it into a perfect triangle if I draw it well enough. So it's supposed to be longer. So it will turn into a perfect triangle, and then you see that that let's say this A, B, and C. So realize that this whole thing is B, by the way. So I'm gonna only write A for now. A. Since realize that this is a straight line, right? This is a straight line. So this is a straight line. So here is 180 minus A. And remember, A is for this force, F1, F2, F1. So F1 and F2 and F3 can be anything, but make sure that you get the main concept right. It's the angle, the force that you're referring to is the angle facing it, or in this case, it's against it. So so here is F1. Then realize that these are the same length. And then for B, yeah, for wait. For B, wait, give me a bit. Okay, okay. So yeah, A, 180 minus A, remember? So F1 over sine A. Remember, A is, sine A is equal to sine 180 minus A. That's why I can use it immediately. In a triangle, you want to use the angle inside the triangle. But I can use the angle, like the big angle immediately, because it is equal. Okay, so oh, I know already. Remember how I mentioned that this whole thing is B, right? Then here is 180 minus B, remember? Because it's a parallel force. So here's 180 minus B. Yeah, if you don't know why it's 180 minus B, learn your maths. 180 minus B. And then it's the same force as this, which is F2. So F2. So you can see that the B is opposing here, and the 180 minus B is opposing here. And sine 180 minus B is equal to sine B. So equals to F over sine B. And then same thing for C, 180 minus C. And then here is F3. So using sine rule, you get F1 over here, this whole thing, equals to F2 over here, equals to F3 over here. Since sine 180 minus theta is equal to sine theta, we can immediately use this thing instead. But again, if you don't wanna understand, if you don't wanna think too much, FA over sine A equals to FB over sine B equals to FC over sine C. This is called sine rule or Lami's theorem. So okay, so I think that's for forces in equilibrium. Let me see if there's anything more. Please tell me there's nothing more. Oh, okay, elasticity. Okay, that one already thought. So the last one. How about resolution of forces? Resolution of forces using this thing. Let me just see if there's any equation that I can find. Okay, this is using a sine rule and cosine rule. So as I said, they don't actually use sine and cosine rule much. So you only have like a few examples to look at. So that's why I had to depend on teacher on learning this. Right, let me just go back to the question just now. The topic just now. With resultant force. So so if you have a lot of forces acting together, you have two ways to solve it. One is triangle of forces or equilibrium, which only happens in equilibrium, and the other one is resolution of forces, which is trying to make them all into this and this. So yeah, you do this when you know that the resultant force is not zero. So if it says that the force is in equilibrium or force is suspended, force is stationary, that means your resultant force is zero. But if your resultant force is not zero, you have to use this method. So how do you do the method? First of all, identify all of your forces. Number one is that there is friction. You have friction here. Number two is that you have a weight. Number three is that there's a normal reaction. And lastly, you have T, which is the pulling force at a certain direction. And it is pulled at 30 degrees. So remember, if you don't remember, go back to what I said earlier. Where you here's Fx, here's Fy, then Fx equals to I think it was Fx equals to F cos 30 and Fy equals to F sin 30, if I remember correctly. Let me just look at it to double check. Yeah. So Fx equals to F cos 30 and Fy equals to F sin 30. If you don't remember, go back to where I mentioned, go back to what I mentioned with the whole triangle thing. Because remember, when you're trying to separate them into two forces, you want it to be at the x and y axis. So this is definitely going to be 90 degrees. So you can make a parallel line with the same length. So it will be a right angle triangle. So that's why you can use sine and cos, because it has a right angle triangle. So opposite over hypotenuse and adjacent over hypotenuse. So yeah, but I normally just do it manually anyway. So I do like here's Fy, right? Fy, and then here's theta, and then here's F. So sine theta equals to opposite Fy over hypotenuse. So Fy equals to F sine theta, and the same thing for cos. So you have to do that. So I'm gonna erase this part. Just remember the formula at least. Okay, calculate the magnitudes of the horizontal pole. Oh my god, what happened? Oh, I think I pressed this on accident. Okay, calculate the magnitudes of the horizontal component and the vertical component of the pole. So remember, you want to find you want to find. Oops, I went too far. Okay, you want to find the magnitudes of the horizontal component, which is Fx. Horizontal is Fx. Okay, wait, what can I draw here? Okay, horizontal is Fx. Horizontal. Here is vertical. So how to find the horizontal force? You know that the pull is 36. And you know that Fx equals to F cos 30. Because is 30 degrees given. So equals to 36 times cos 30, which is 31.818 Newton. So yeah, you look here. This is cos 30 times 36. This is sin 30 times 36. No, this one. This one. Sin 30 times 36. Yeah, I looked wrongly. So I think it's over here. So now you know that. So after you do the calculation, you know that the angle going, the force going upwards is 31.18, and the force going to the right is 31.18, and the force going upwards is 36. The reason why we can divide it into two is like remember how just now we did? We have two forces acting together, and then it'll create a resultant force in the middle. Here it's the same thing here. If there's a resultant force in the middle, we can separate it into two different forces applied at different directions. So that's why we can separate it into two, but you have to use the proper formula. So yeah, I hope that will be understandable. This is very hard to explain, so yeah, you do that, and then number 2, determine the magnitude and direction of the resultant force acting on the block. So how do you find the resultant force? How do you find the resultant force? First of all, as I said, you already separated them into vertical component and horizontal component. So you have to be careful now when you're playing with this. Give me a wait. Okay. Okay, this one is wrong. It's FR. Okay. Yeah, this the one that I got confused. So what you want to do is you want to solve them separately first. So yeah, you want to solve them separately first. So you want to do the vertical one first and horizontal one first. I mean, so you do the horizontal first. You know that this thing is 36 cos 30, which is 31.18. And then you know that there is a frictional force going the opposite direction. So you have to minus. So it is 31.18 minus 20. So it is 11.18 Newton. So the overall force going this way is 11.18. The resultant force for the x-axis, or the force going to the right. And then you're going to find the force going upwards. Or force for the vertical axis. So is it going upwards, or is it going downwards, or is it not moving at all? So yeah. For here, we know that the weight is what? Wait. Okay. The weight is 24. Yeah, the weight is 24 here. And the normal reaction is 6. So sub it in. The result of vertical components is the sum of all forces, and you have to account for the direction. So it is 18 going up, 6 going up, 24 going down. So the answer is you get 0. So most of the time you will be able to find out that the resultant force is 0 because it is on the ground. It is not moving on the ground. But you need to be careful because sometimes the vertical component is not 0. So if I'll get to what happens if it's not 0 later. So since you know that this is 0, so you know that the overall direction is 11.18 Newton to the right. So you find that. So that's your answer. So the resultant force is 11.18 to the right. Because you know that it's only moving right. It's not moving upwards or downwards because the resultant force for vertical is 0. What if it's not 0? I don't know if it'll come out in an exam, but what if it's not 0? If it's not 0, then what you have to do is you will have a force going here and a force going upwards, right? And then you have something else here. What you have to do is you have to use Pythagoras, or you have to use Pythagoras, and find the force in the middle. But that's just very easy lah. A square plus B square equals C square. So yeah, A square, B square, C square. So you're gonna find the angle in the, so if you're gonna find the resultant force when the horizontal components and vertical components each have their own magnitude of forces, like one of them is 18, the other one is not 0, then you have to use Pythagoras to find the final force in the middle. And remember to use sine rule to find out the where the force is coming from, and to find out the angle of the force is acting on. So yeah, I hope you get it. I think I did really better at explaining, but my voice is I'm not gonna do this again. I hate this chapter so much. Let me just try and go through one more, I guess. Okay. The block is sliding down the plane. Okay, the block sliding down on the plane. Number 1, sketch the component of the width of the block parallel to the inclined plane, and the component of the width of the block perpendicular to the inclined plane. So it's asking you to separate them into this and this. So because remember, it is parallel is same direction as this. Perpendicular is exactly 90 degrees between them. So you have fx and fy. I think it's like that. Oh no, it's double leg, I think. Yeah, this y, this x. So fy, fx. Oh, see this weight, wy and wx. So that's the first part. You want to section it into two components. You know the weight, then you want to separate it into the weight here and w and wx. Now some people might ask me, how do you get the 60 degrees? Wait, let me remember how you got it. The easiest way that I can think of is this is a triangle, right? So here's 60. Since I know that this is exactly going downwards, so this is 90 degrees definitely. So here has to be 30, right? Because 180 minus 60 minus 90. So here's 30. And then remember that this is also a right angle. So it is 90 minus 30. So this thing is also 60. So you have to play around with the angles. So yeah, if you don't get what I'm saying, this is a triangle. This is the angle 60. So the sum of the three of the angles in a triangle is 180. So you will get 30 here. You want to find the angle acting in this direction. So it is 90 minus 630. I know it's 90 because, as I said, it is perpendicular, so it is 90 degrees. So yeah, I think I explained it good enough. Actually, I don't think so, but it is what it is. Then I think after that, it asks you to find the... Wait, did it ask you to find? Oh yeah, it asks you to find. Determine the resultant force acting on the block. So how do you determine the resultant force acting on the block? First of all, identify all the forces. Since it's free body diagram, free moving, smooth inclined plane. Smooth inclined plane meaning there is no friction. You are considering the fact that there is no friction. So there's only a weight pulling downwards, and then you have a weight perpendicular to the thing. Yeah, you have to weight that is separated into two components. One is going with the plane. One is going perpendicular to the plane. So this is one direction. This is another direction. So you want to find this direction first. So y. So since it's here, I believe it's cos. Yeah, wy equals to 24. The angle here is 24, I think. Yeah. This thing is 24. So 24 cos y and 24 cos 60. So yeah, you have to be careful. I'm gonna draw it again to make sure that you guys actually get it. So it's 60. Here is 24. So this is a right angle triangle, right? Here. So cos is equal to adjacent, which is wy over hypotenuse. Hypotenuse 24. So cos 60 is equal to wy over 24. So wy is equal to 24 cos 60. Okay. Then you find it, it's 12 Newton, and then you find the resultant force. You find the force for X as well, WX as well. So WX is 20.78 Newton. And then after that, you want to find the resultant force, right? So they give you the normal reaction already. So the total force for the vertical component or one direction going up and down is 12 minus 12, so it's 0, again 0. And then you know that there's no friction, so the force going horizontally in this case, because remember the thing is sliding down in this direction. So if you look at it from like a bend view, it will be horizontal. So resultant force is 20.78 going this way. Oh my god, there's a lot of stuff there. So yeah, now you know that the resultant force is 20.78 going down this way. If they ask you at how many degrees to the plane, if they ask you how many degrees to the plane, I would say what are? I forgot what I would write. Oh, you just to say 20.78 Newton parallel to the plane. So you know, so for this one, if you but I don't think teacher will mind much for this question if you don't give the direction. Because it says here calculate the oh never mind, it doesn't say there. You should. But yeah, I will be safe and I will try to find the angle, but yeah, I'm not so sure on how to explain it properly. I'll show you how I get it though. So how do I get the resultant force acting on what part? So it is what So this is 20.78, right? Where does it act on? It acts on the horizontal part of this thing. So it acts on the horizontal part of this. So it is since it's parallel. Since it's parallel kan, you just say 20.78 parallel to the inclined plane downwards. Not downwards, yeah. Okay, 20.78 Newton downwards and parallel to the inclined plane. Okay, I should know if I'm actually getting if I'm actually explaining well now. But if they ask you to specify the direction, you say the resultant force is parallel to the inclined plane. Okay, lastly you want to find the acceleration. So you know that the resultant force is 20.78. Then you know that F equals to ma. You know the S as well. So you just find A. Okay, I think I'm tired of this.